So today is the week 9 of our semester, and we will be talking about the climate. That's how do the troposphere and stratosphere differ, and we will talk about some factors in natural climate variability. We will explain the greenhouse effect and how it is changing our climate. We'll also talk about that how do we know the nature and cause of certain recent climatic changes. They are affecting our climate, or they are leading to the global warming. We will also list some of the effects of climate change and some strategies for minimizing this global climatic change. Let's start with a case study that's about the shrinking Florida. What will Florida be like when its beaches are underwater? So it's hard to say precisely, but the tourism industry is sure to struggle as beach resorts and coastal cities they flood. The interior of the state will become more crowded because the more residents of coastal cities they are forced to move inland. That means away from rising tides and storm surges. Because of the drought and hot summers, they will likely make much of the state's agriculture uneconomical. Inland Florida is likely to have much less forests as dry summers produce more frequent larger wildfires. So this might be seen an apocalyptic scenario, but it confirms to what the climate data indicates. So we can say that climate warming has already caused many global mean sea level to rise about 20 centimeters, or we can say 8 inches in the past century. So that might sound a slight, but it brings higher storm waves, or we can say the tides. So it has been estimated that by 2050, another 25 centimeter or 10-inch of sea level rise is likely, and by 2100, sea levels is expected to be 1 meter higher. Why is this sea level rising? So thermal expansions, they explain about half of the change so far because water expands slightly as it warms. Melting land-based glaciers, they contribute about 1/4 of the increase, and melting ice sheets, they contribute the remainder of this. This balance may change in the coming decades, but it has been found that Antarctica's land-based ice sheets have begun to flow to the sea at an accelerating rate, and Greenland is melting at a rate few climatologists they expect that this Greenland is melting uh, at a higher rate. So Greenland's massive ice cap holds enough water to raise this sea level by about 6 meters. So the degree of melting is likely to take about centuries, but there are intermediate changes that will cause tremendous damage. There are many policymakers that don't like to talk about the climate change that will affect all of us. So the pattern of warming has become more and more clear with more and more heat, drought, and storm records that are piling up in recent years. Certainly, we can say that climate change that will present a different world to our grandchildren because many state governors have refused to discuss climate science in emergency planning. For example, in planning for hurricanes and heat waves, the federal agency, Emergency Management Agency, has threatened to withhold the funding from states that ignore spending on the climate threats. So you can imagine that if we don't talk about the climate change, as many of the policymakers, they don't like to talk about those climate changes. So how that will affect our grandchildren. The economic and social threats are just as real as the environmental costs. So in this chapter, we will examine how our climate works, what causes the temperature changes, and what are the factors that are leading to recent anthropogenic, or we can say human caused climate shift, as all of us know that this is the humans that shifted this climate. So we will also examine some of the many steps that we can talk to reduce these changes and their impacts. Let's start with the atmosphere, what atmosphere means. We know that clean dry air is 78% nitrogen and almost 21% oxygen, with the remaining 1% that's composed of argon, carbon dioxide, and a variety of other gases. Water vapor, that's the water in the gaseous form, it varies from about 0 to 4%. So, depending on the air temperature and available moisture. There are certain minute particles and the liquid droplets that are collectively called as aerosols. They are suspended in the air. Atmospheric aerosols and water vapor, they play very important roles in the Earth's energy budget and in rain production. The atmosphere has four distinct zones of contrasting temperature due to the differences in absorption of solar energy. The layer that's closest to the Earth's surface is the troposphere, which experiences daily temperature changes, wind, and precipitation that we collectively call as weather. Within the troposphere, the air circulates in great vertical and horizontal convection currents. Then the other zone is the stratosphere that has almost no vapor, water vapor, and nearly 1,000 times more ozone. A sudden reversal of the temperature gradient, it creates a boundary called the tropopause. This temperature boundary occurs between the ozone molecules and in the stratosphere that absorbs the solar energy. In particular, the ozone absorbs the ultraviolet radiations. So this absorbed energy makes the stratosphere warmer than the upper troposphere. So the stratosphere extends about 50 kilometers from the tropopause. It's a far more dilute than the troposphere. Above the stratosphere, the temperature diminishes again and creating the mesosphere or the middle layer. Like here you can see the mesosphere. That's so this mesosphere is actually the thermosphere. That's the heated layer begins at about 50 kilometers. This is a region of highly ionized, electrically charged gases that are heated by a steady flow of high energy solar and cosmic radiations. In the lower part of this thermosphere, intense pulses of high energy radiations cause electrically charged particle ions to glow. This phenomenon is what we know as the aurora borealis or aurora australis or northern and southern lights. The absorbed energy by gases, it warms the atmosphere slightly, so most of the energy is in the form of light, or we can say infrared heat energy. Some incoming solar energy is reflected by bright surfaces like snow, ice, or sand. The rest of that is absorbed by the Earth's surface by water. So surfaces that reflect the energy, they have a high albedo. When we say albedo, it means the reflectivity, that how effectively they reflect rays. So fresh snow and dense clouds, for example, they can reflect as much as 85 to 90% of light that fall on those surfaces that absorb energy. So they have a low albedo and generally appear dark. Black soils, or we can say asphalt pavements and water, for example, they have low albedo with reflectivity as low as 3 to 5%. So, of the solar energy that reaches the outer surface, one fourth of that is reflected by the clouds and atmospheric gases, and one fourth is absorbed by carbon dioxide, water, vapor, ozone, methane, and a few other gases. And half of the incoming solar radiation reaches the Earth's surface. Talking about the greenhouse effect, that is something like the glass of a greenhouse. The atmosphere transmits sunlight, but it traps some heat inside. So, also like a greenhouse, the atmosphere lets that energy dissipate gradually to space. So, if our atmosphere didn't capture this re emitted energy, the Earth's average surface temperature would be about minus 6 degrees centigrade rather than the current 14 degrees. So, thus, energy capture is necessary for liquid water on Earth and for life. The balance of the rate of incoming energy and outgoing energy, it determines the temperature inside the greenhouse. The policy issue that faces us is that we are slowing the rate of heat loss. That means we are increasing the heat storage in our greenhouse. We are doing this by adding more of the greenhouse gases like the carbon dioxide, methane, nitrous oxide to the atmosphere at the levels the Earth has not seen since before. So these greenhouse gases, the carbon dioxide, methane, nitrous oxide, so their levels have been increasing in the atmosphere that we have never seen before. So the question is whether we will be able to agree on changing this trend or not, and how we can change this trend, how we can reduce this greenhouse effect. That means the increasing levels of these greenhouse gases. It has been found that the evaporated water it stores and redistributes the heat. So we can imagine the sun that's shining off the Gulf of Mexico in the winter. So warm sunshine and plenty of water, it allows the continuous evaporation that converts an immense amount of solar energy, that's the light energy, into latent heat stored in evaporated water. Now imagine a wind is blowing the humid air north from that gulf towards the Canada. So the air cools as it moves north. Cooling causes the water vapor to condense. So there might be rain or snow that falls as a consequence. So here you can note that it's not only the water that has moved from Gulf to the Midwest, so 580 calories of heat have also moved with every gram of moisture. This heat and water that have moved from a place with strong incoming solar energy to a place with much lesser solar energy, much less water. This redistribution of heat and water around the globe is very essential to life on Earth. Talking about the climate changes over the time, it has been found by various climatologists like Wallace Brooker. He said that climate is an angry beast. That means we are poking it with the sticks. He meant that we assume our climate is stable, but our thoughtless actions may be steering it to sudden and dramatic changes. That means we humans are actually disturbing the climate with the different human acts or activities. So, how stable is that climate? It depends upon the time frame you consider. So, over centuries and millennia, we know that climate shifts somewhat, but usually we expect little change on the scale of a human lifetime. The question now here is whether that is reasonable expectation. So, if the climate does shift, how fast it changes, and will those changes mean for the environmental systems on which we depend? We will be talking about these questions in our coming slides. So if we talk about the ice cores, they tell us about the climatic history. So every time it snows, small amounts of air are trapped in the snow layers. Climatologists, they have discovered that by drilling deep into an ice sheet, they can extract ice cores from which they can collect the air bubble samples. These samples taken every few centimeters, they show how the atmosphere has changed over time. So ice core records have revolutionized our understanding of climate history. We can now see how concentration of atmospheric carbon dioxide have varied and detect the ash layers and spikes or increase in those sulfate concentrations that record the volcanic eruptions. In Greenland and Antarctica and other places where the cold is persistent, yearly snow slowly accumulate over the centuries. So new layers compress those lower layers into the ice, but still tiny air bubbles they remain. So these climatologists, they actually take those each bubble is it, which is a tiny sample of atmosphere at the time that snow fell. What actually causes the natural climatic swings? These climatic swings, we can call them as the Milankovitch cycles, because there was a Serbian scientist, Milutin Milankovitch, who first described them in 1920s, the climatic swings. These swings are called as, or these shifts we can call as Milankovitch cycles after his name, Milutin Milankovitch, who was the first scientist who described them in 1920s. So there are three of these cycles. Number one is the Earth's elliptical orbit stretches and it shortens in 100,000 years cycle. Number two is the Earth's axis changes its angle of tilt in 40,000 years cycle. That's the other shift. And number third is the that over 26,000 year period, the axis wobble like an out of balance spinning top. So these cycles, they cause variations in intensity of incoming solar energy at different latitudes and in the intensity of summer heating, or we can say the winter cooling. Talking about the oscillations that's called the Nino or Southern oscillations, it's probably the best known oscillations that have been these coupled ocean atmospheric oscillations in all the world's oceans. But this El Nino Southern oscillation, or we can say ENSO, is probably the best known. ENSO affects the weather across the Pacific and adjacent continents, causing the heavy monsoons or serious droughts. So, on the scale of years or decades, it has been found that climate changes according to these oscillations, the El Nino or Southern oscillations in the ocean and atmosphere. The core of this system is a huge pool of warm surface water in the Pacific Ocean that sloshes slowly back and forth between the Indonesia and Southern America. So, like the name implies, it makes some oscillations like water in a giant bathtub. So, most years, steady equatorial trade, it winds holds this pool in place in the Western Pacific. So, from Southeast Asia to Australia, this concentration of warm equatorial water, it provides the latent heat, or we can say the water vapor, that drives those strong upward low pressure convections in the atmosphere, resulting in heavy rains in Indonesia, which support those Indonesian forests, the tropical forests. So these El Nino southern oscillations, they affect the weather throughout the Pacific, causing heavy monsoons or we can say severe droughts. So how do we know that the climate is changing faster than the usual? The observatory was established in 1957 as part of an international geophysical year to provide atmospheric data in a remote pristine environment. So different measurements that were taken by atmospheric chemist Charles David, Charles David Keeling showed that carbon dioxide levels increase about 0.5% per year. There was a Keeling curve which has been continuously updated shows that carbon dioxide concentration have risen from 315 parts per million in 1958 to about 393 parts per million in 2012. So this is the Keeling's graph that he said that from 1958, the carbon dioxide concentration has increased up to 2012. Measurements of atmospheric carbon dioxide taken at the top of Mauna Loa, Hawaii show an increase of about 2.2% in recent years. So monthly mean carbon dioxide, you can see that the red here and the average carbon dioxide, that's the black, track closely with the general trend in global temperatures, that's the blue one. But among most climatic scientists who worked with the data and models, that there is no disagreement about the direction of change. The evidence shows the minor differences among models, but no disagreement. So the evidence shows unequivocally, as in the Mauna graph, that climate is changing. The global average is warming because of increased retention of energy in the lower atmosphere. As we all know that this climate is very complex, the climate scientists worldwide have collaborated in collecting and sharing this data and in programming models to describe that how the climate system works. So like we saw in this graph that how these carbon dioxide concentrations are increasing. From 1985 it was like 319 parts per million, so it's increasing. What do we mean by IPCC? So IPCC is the Intergovernmental Panel on Climate Change. That's the most comprehensive effort to describe the state of climatic knowledge about these. The IPCC, it brings together the scientists and government representatives from like about 130 countries. And the main aim of this IPCC is to review the scientific evidence on the causes and likely effects of human caused climate change. As we all know that it's the humans that are actually leading to the global warming because of our activities that we perform here on Earth. So in 2007, the IPCC, that's the Intergovernmental Panel on Climate Change, it issued its fourth assessment report. The conclusion from that report was that there is 90% certainty that the climate change is caused by the human activities. There were some other reports also that raised this certainty to 99%. The report that was submitted by the IPCC, it also reflected some scenarios for predicted emission of greenhouse gases. So for each scenario, the IPCC modeled the future emissions starting in 2007. Droughts, floods, crop failure, and waves of refugees might result because of these greenhouse gas emissions, or temperature rises, or sea level and energy use have accelerated faster than the IPCC projections. This is a serious concern that has increased the heat stress and drought, which could cause increased deaths as well as the crop failure and new waves of these refugees from drought-stricken regions. There are certain policymakers that have made little progress in finding the solutions for this global climatic change. The question is whether the sacrifices need necessarily be as big as some policymaker suggests. Climate scientists point out that shifting our energy strategy from the coal to wind or solar and greater efficiency could produce millions of new jobs and save billions in healthcare costs associated with the coal burning. Like we already discussed, the main greenhouse gases that are the carbon dioxide, methane, nitrous oxide that are leading to the global climate change. It has been found that burning of fossil fuels is responsible for about 80% of carbon dioxide emission. We have certain cement production furnaces and burning of forests and grasslands that are also some major resources. Together, these release more than 33 billion tons of carbon dioxide every year on average. Or we can say about 3 billion tons of this excess carbon is taken by the terrestrial ecosystem, and around 2 billion tons are absorbed by the oceans, leaving an annual atmospheric increase of about 4 billion tons per year. It has been assumed that if the current trend continues, carbon dioxide concentration could reach about 500 parts per million by the end of 21st century. Now talking about the methane, which is much less abundant than carbon dioxide, but it absorbs 23 times as much infrared energy per molecule and is accumulating in the atmosphere about twice as fast as carbon dioxide. Methane can be produced anywhere organic matter decays without oxygen, especially underwater. The natural gas, which is mainly methane, derives from ancient swamp material. Methane is also released by certain ruminant animals, wet rice paddies, coal mines, landfills, the wetlands, or the pipeline leaks. So they are all the sources of this methane emission. Now, moving to the nitrous oxide emission, it's mainly produced by chemical reactions between atmospheric nitrogen and oxygen, which combines in the presence of heat from internal combustion engines. So other sources are burning of organic material and soil microbial activities. They also lead to the nitrous oxide emissions. So what consequences do we see? The American Geophysical Union, one of the nation's largest and some most respected scientific organizations, they have stated that as best as can be determined, the world is now warmer than it has been in the last 2000 years. So since the beginning of civilizations, we saw that the world is becoming warmer. There is an increase in global warming. So if the current trend continues by the end of century, it will be hotter than at any point in the last 2 million years. It has been found that the average global temperature has climbed about zero point 0.6 degrees centigrade in the past century, and 19 of the 20 warmest years in the past 150 have occurred since 1980. So we can say that this warming has resulted in some important changes. Global sea level has risen approximately 20 centimeters. The permafrost is melting. Houses, roads, pipelines, sewage systems, and transmission lines, they are being damaged as the ground sinks beneath them. The Arctic sea ice is only half as thick now as it was 30 years ago, and Antarctic ice shelves, they are breaking up. We have certain satellite images and surface measurements that show that growing seasons are now as much as 3 weeks longer in northern Eurasia and North America compared to 30 years ago. Certain southern plants and animals, they are moving into Arctic regions, while the Arctic species like musk ox, caribou, walrus, or seal, they are declining. Droughts are becoming more frequent and widespread. The plants and animals are breeding earlier or extending their range into new territory. The coral reefs worldwide are bleaching, that's losing key algae. This bleaching means the losing the colorful algae they rely on for survival as water temperature rises above 30 degrees centigrade. Marine ecologists they worry that warming oceans could be the final blow for the coral reefs, which are already threatened by pollution, overfishing, and for the fisheries and ecosystem they support. So this bleaching, or we can say losing bleaching means losing the colorful algae they rely on for survival. So this change in the color of the algae, it happens because the water temperature of the oceans it's rising above 30 degrees centigrade. There has been some sharp declines in ice-dependent species. Most of them have lost half or more of their populations. The mountain glaciers, they are retreating except where snowfall has increased, for example, including Montana's Glacier National Park. Here are some evidence of climate change. That's the changing climatic range for growing wheat. The climatic conditions for farming, they are also shifting, and it has been assumed that by 2050, the wheat production may have shifted to central Canada. So we all know that the growing crops, they all depend upon the climatic conditions in addition to these the soil conditions or how the soils are. It has been found that controlling emissions is cheaper than cost of climatic change. A 2010 study by Pew Trust estimates that cost of lost ecological services by 2100. So costs include the factors such as agriculture productivity that's lost from the drought, damage to infrastructure from flooding and storms, lost biological productivity, healthy costs from heat stress, and lost water supplies. The Pew report found that climate change is likely to cost between $5 trillion and $90 trillion by 2100. So in a study that was issued on behalf of British government, Sir Nicholas Stern, which is the former chief economist of the World Bank, he estimated that cumulative cost of climate change equals between 5 and 20% of annual global gross domestic product. So why there are disputes over the climatic evidence? Climate scientists they offered the following responses to some of the claims on in the popular media. So reducing the climate change it requires the abandoning or our current way of life, but it does require that we use different energy sources. A comfortable lifestyle it requires high carbon dioxide output. So natural changes such as solar radiation that can explain observed warming, like the changes are slight and they do not coincide with the climatic changes. There are certain temperature changes that are leveling off. We had cool temperatures and snowstorms last year, not heat and drought. Some climatic scientists, they don't even know everything and they have made errors and misstatements. So there was a fraud in data collection that's almost unheard of in science. So these are the different disputes over the climatic change. Talking about the solar energy usage, the solar energy received at the top of the Earth's atmosphere has been measured by satellites since 1978. So it has followed a natural 11-year cycle of small shifts, but no overall increase. You can see here at the bottom. So over the same period, the surface temperatures have increased markedly. There are certain solutions for this. The former President Bill Clinton has argued that combating the climate change doesn't have to mean economic hardship. It could be the biggest development stimulus since World War II, creating millions of jobs and having these and saving trillions of dollars in foreign fuel imports. So, what are the different strategies that we have available? There are many ways we can control the greenhouse gas emissions. The coal producers more carbon dioxide. That means it has been found that burning of the fossil fuel, it produces more carbon dioxide per unit energy than any other fuel. So we can consider that about $120 billion per year in tax credits for oil and coal development, which transfer those operating costs to taxpayers. We can plan the cities and transportation system to provide better alternatives to private automobiles, which are the main way individuals contribute to our climate impacts. We can account for the hidden costs, for example, the health costs, biodiversity, or some recreation costs, military expenditure to protect the oil fields. And when these costs are no longer hidden, it will be clear that fossil fuels are not cheaper than the alternatives. We can invest in new technologies. The price of solar power, it has plummeted in several years, so making the cost of new solar, wind, or coal power equivalent. We have certain international protocols that have tried to establish the common rules. Many of the largest these businessmen in America, they have joined the environmental groups to call for strong national legislation to achieve the significant reduction of greenhouse gas emissions. These companies they would prefer a single national standard rather than a jumble of conflict between the local and state rules, which cost them time, money, and sometimes the contracts with potential trading partners. A wedge approach, it could fix the climate problem. Pacala and Sokolo's paper described about 14 wedges, which represents that 1 billion tons of carbon emission avoided in 2058 compared to a business as usual scenario. So to achieve the stabilization, we need to reduce our annual carbon emissions by about 7 billion tons, or we can say 7 gigatons per year within those 50 years. So none of the 14 wedge options is going to please everybody, and some will be more popular than others, but the potential benefits of the entire portfolio are large enough, and that not every option must be used. A wedge approach could use the multiple strategies to reduce or stabilize these carbon emissions rapidly and relatively cheaply. Even if just half of these wedges could level off our emissions, accomplishing all of them, they could return to levels well below those that were in the Kyoto Protocol. Proponents of carbon management, as these various projects are called, argue that it may be cheaper to clean up fossil fuel effluents than to switch to renewable energy resources. So by far the easiest way to remove the carbon dioxide from a coal-fired power plant is the integrated gasification. combined cycle. That's the IGCC technology, about which we will talk about detail in the chapter 12. So geological formations around the world could hold hundreds of years with worth of carbon dioxide at current production levels. So these formations, however, are not necessarily near the sites where we now produce the carbon dioxide. Concluding today's chapter, we have talked about that temperatures are now higher than they have been in thousands of years. And climate scientists, they say we do not reduce the greenhouse gas emissions soon, the drought, flooding of steel may be inevitable. Certain exhaustive modeling and data analysis by climate scientists, they show that these changes can only be explained by human activity. We talked about the wedge proposal, which is the stabilization wedge proposal, is a list of immediate steps that could be taken to accomplish needed reductions in greenhouse gas emission. So that was all about today's lecture. Thank you so much.